Welcome to the IE ratio calculations presentation. A copy of this PowerPoint is available for download and printing if you choose, as well as a worksheet with an answer key. I know this topic gives some people a little bit of angst because there's some math involved, so we'll go over the calculations and how you can manipulate them to find your variables within this presentation. So when we're talking about IE ratio calculations, we're using several variables. We're going to look at the respiratory rate, the I time, the E time, the total cycle time, and then the IE ratio. It's also important to note that the IE ratio, when we're talking about that ratio, the I time is the single constant and the E time will be the variable. So when we're solving I time and IE ratio, it's always a 1 to something ratio, and the 1 represents the 1 unit, represents your I time. So whatever your I time is, that's the 1, and then the E time will be the multiple, how many I times there are in the E time, and that will give you your ratio. So let's get started. We're going to calculate IE ratio, rate, and total cycle time if we know that the I time is 1.2 seconds and the E time is 3 seconds. And so when we look at our formulas above, we have enough information to solve for several different variables. So with I time and E time, we can solve for total cycle time. We can solve for IE ratio. So let's do that. When we take our total cycle time formula, we know that that is the I time plus the E time. And in this case, we're given both of those variables. I time is 1.2, E time is 3 seconds, so it's very straightforward. Our total cycle time, or the total amount of time spent breathing in and breathing out, per breath is 4.2 seconds. We're just adding those together. Now, we can figure out our total respiratory rate if we know that the total cycle time is 4.2. Look at our formula above. Respiratory rate is 60, because there's 60 seconds within a minute, and we're going to divide that 1 minute time by the breath total cycle time. So how many of these can we get in a minute? So 60 divided by 4.2, we are breathing 14 of those every minute. So our rate on the machine would be 14. And the last calculation I'm going to go over is the IE ratio. Again, we're given the I time and the E time, and we look at IE ratio formula. It's just the expiratory time divided by the inspiratory time. And here we have our 3-second expiratory time divided by 1.2, our inspiratory time, and that gives us 2.5. So what does 2.5 represent? It is the ratio of expiratory time to inspiratory time. And as I said previously, the I time is always the constant or the 1 variable, so therefore the IE ratio is a 1 to 2.5 ratio. You can also check your work to see if it's correct. Is 2.5 the correct ratio? Well, if there are 2.5 I times in our E time, we can take 2.5 times our I time, and that should give us 3, and it does. So our math is correct. Now we'll look at being given other variables, such as respiratory rate and IE ratio. And we're going to figure out how many seconds are for inspiratory time and how many for expiratory time. So if the vent is set at 12 breaths per minute with an IE ratio of 1 to 3, how many seconds do we have for inspiratory time? And if we use our math formulas, we can take our total cycle time, which is 60 divided by our rate, and that gives us 5-second total cycle time. So for every in and out, every breath cycle, we have 5 seconds to do that. Now we're going to take a variation of the total cycle time formula to calculate inspiratory time. So if you take total cycle time and divide it by the IE ratio, that will give you inspiratory time. So therefore, when we plug our numbers in, total cycle time is 5. The I to E ratio, we're going to add those two variables because we want to know how many, each one is a chunk or a component of the breath. So in total, there are 4 of those because we said that expiratory time is 3 I times, okay? So that gives us 4 equal components of the breath. And if we take our total breath, 5 seconds, divide it by those 4 chunks, and each chunk is going to be worth 1.25 seconds. And so our ratio of 1 to 3, we know that the I time then is 1.25. And if we take 3 of those, we know the E time is going to be 3.75. So it's pretty straightforward. Now, a little note about IE ratio. What is a normal IE ratio? Well, for you and me, probably a 1 to 2 ratio is very comfortable for our breathing, maybe a 1 to 3. But for somebody with air trapping, autopeep, somebody that has like bullous lung disease or status asthmaticus, those types of patients aren't able to exhale their breath in the normal time frame. They have air trapping. And so for those patients, we have much longer I to E ratios, usually a 1 to 8 or 1 to 10 or a 1 to 12 ratio. So expiratory times may not be short, like 2.5, 3, 4 seconds. They may be 8, 9, 10, 12 seconds long. So their respiratory rates will be much slower, and their expiratory times will be much longer so that they can exhale the trapped gas. Our last calculation is figuring out the flow rate. Some ventilators don't have a set inspiratory flow rate, or you don't know what the inspiratory flow rate is, and you can calculate that from some variables given. And that formula is minute ventilation multiplied by the I plus E time, not ratio. Inspiratory plus expiratory times. So in our example, we're given a tidal volume of 600 and a rate of 12. That allows us to calculate for minute ventilation, if you remember from the previous chapter. So minute ventilation, in this case, is going to be the 600 times 12. So that's our minute ventilation there. And then we're going to multiply that number, which is 7.2, by the inspiratory time plus the expiratory time, which we're given here. And so that'll be 7.2 times 4.5, which will give us a flow rate of 32 liters per minute. So if you wanted to set an expiratory time of 3 seconds, or an I time and E time of 3 seconds, and you wanted to know how much flow the ventilator was delivering an inspiratory flow to your patient, this is the formula you would use to do that. And this concludes the IE ratio presentation. Thank you.